Number 12 says, what is the limit as h approaches 0 of cosine of pi over 2 plus h minus cosine of pi over 2 all divided by h? This problem looks like a complicated limit problem, but is actually a derivative problem in disguise. In order to be successful with this problem, you need to be familiar with the limit definition of the derivative. If you want to find f prime x, which is the derivative of f at x, we want to find the limit as h approaches 0 of f of x plus h minus f of x over h. Now take a moment to look at what I just wrote and compare it to the original problem. It looks pretty similar, and that's because in this problem we are trying to evaluate the derivative of cosine x at pi over 2. So to solve this problem, this is going to equal the derivative of cosine x at x equals pi over 2. One of the derivatives that you just need to know is cosine. There are several transcendental functions like e to the x, the natural log of x, sine of x, cosine of x, where you're just expected to know what those derivatives are. The derivative of cosine x is negative sine x. And so if we want to evaluate the derivative of cosine x at pi over 2, then this will equal negative sine of pi over 2. Here, you're just going to have to be familiar with some key angle measures around the unit circle to be able to evaluate sine of pi over 2. This is just another one of those little facts that you're just expected to know. So just as a little reminder, the unit circle is a circle with radius 1 centered at the origin, and it's useful in evaluating trig functions. The points along the circumference of the circle give us cosine and sine values. 0 radians is here. Pi over 2 radians, which is equivalent to 90 degrees, would have a terminal side along the positive y-axis. Pi radians is equivalent to 180 degrees, and 3 pi over 2 radians is equivalent to 270 degrees. If you go all the way around at 360 degrees, that's equivalent to 2 pi radians. So if I want sine of pi over 2, I'm going to be looking at the point where this terminal side of pi over 2 intersects with the unit circle. There's going to be an x-coordinate and a y-coordinate, and since this circle has a radius of 1, the x-coordinate is 0 and the y-coordinate is 1. For any point on the unit circle circumference, the x-coordinate corresponds to the cosine value of the angle measure in question. The y-coordinate corresponds to the sine value of the angle measure. So sine of pi over 2 is 1, and since it's negative sine of pi over 2, this equals negative 1. Our answer is B.